question F is our last question for the ideal gas law. And for question F, I went ahead and put down your formula for the ideal gas law. I reminded you your R value. I also went ahead and brought in from the formula sheet your conversion factor from millimeters mercury to ATM for units of pressure, because we're going to need that for this question. And I've just given you a general reminder that anytime you're going from grams to moles, you're going to need to use molar mass. So question F says, at what temperature does 5.00 grams of hydrogen gas, H2, occupy a volume of 50.0 liters at a pressure of 761.0 millimeters mercury? I went ahead and laid out all those variables. So you're solving for temperature. Your 5.00 grams of H2, that is your mass that you're going to then need to convert to moles because that's your N value in the equation. Your volume that was given to you is 50.0 liters, and your pressure that was given to you in millimeters mercury, and so we're going to have to convert that into ATM. First thing you want to do is you want to set up your formula. So remember, to isolate for temperature, you're going to divide by moles and R on both sides, and that's going to then cancel them out. So you're ultimately going to be left with the temperature equals pressure times volume over number of moles times the R constant. So let's go ahead and fill this in. My pressure that was given to me in the question is 761.0 millimeters mercury. I can't just leave it there and move on to volume because millimeters mercury is not going to cancel out with units of ATM in my R value. So I need to do a quick conversion right here in the formula. I have millimeters of mercury. I want those to cancel and I want to be left with ATM. So I'm going to go to my actual conversion and I'm going to put down 760 millimeters of mercury in my denominator and 1 ATM in my numerator. And that way millimeters of mercury will cancel out and I'm left with just ATM. Now I can move on to volume. My volume is just 50.0 liters. Liters works with liters in the R value, so I'm all set there. I can now head into the denominator and go to N for moles. I wasn't given moles, I was only given grams, so I can always convert from grams to moles by just making sure that I use my molar mass as my conversion factor. So if I'm starting with 5.00 grams of H2, I need to make sure that my conversion factor for molar mass has my grams in my denominator so that those cancel out and I'm only left with moles of H2. So notice on your periodic table, hydrogen is just straight 1.008, but you're not looking at just straight hydrogen, you're looking at H2, right? So you needed 2 atoms of hydrogen. So that's going to be 1.008 plus 1.008. That's why that was given to you in the problem as 2.016. So now grams of hydrogen will cancel out and you'll be left with moles of hydrogen for your N value. Your R constant never changes. That you're just going to straight plug in to your equation. You just want to make sure that your units are nicely labeled. So now what's going to happen is I'm going to leave this part completely up to you. You're going to go ahead and map this out on your calculator. This is a chance for you to really confirm your calculation skills and to make sure you're comfortable. Remember, you want to use parentheses. What I would do is I would go ahead and plug down 761 divided by 760, get my answer of units of pressure before I then move on and multiply that by my 50 liters. So I would get this part calculated first, get my answer for it, and then multiply it by the 50 liters. Then I would write down whatever my numerator is. I would just put down my answer. For the denominator, this is now where you want to take your 5.00 and divide that by 2.016. Get your answer for that, and then multiply it by your R constant. Whatever your answer is for the entire denominator, That's what you're going to put over here. What I need you to show me on your work for today is I need you to show me your calculation answer, and then I need you to show me your final sig fig answer with your units. That's all you're going to submit for today. This is the end of the assignment.